It's a great sound. The committee will come to order. Good morning and welcome to our first CJS hearing of the 116th Congress. And I want to take just a moment to clarify something. CJS stands for Common Justice Science. This does not stand for Congressman José Serrano. I have no committee named after me. First, I would like to recognize and congratulate my friend and colleague, Mr. Idaho of Alabama, who will serve as ranking member. I look forward to working with you in Congress as we make important decisions on what investments to make and continue our vital role in conducting oversight to ensure the executive branch is spending taxpayer dollars wisely and investing in our nation. I also want to welcome back returning members of the subcommittee, including our Vice Chairman, Mr. Cartwright of Pennsylvania.
Thank you.
Ms. Meng from my home state of New York. They'll be joining us in a little while. Ms. Roby of Alabama and Mr. Palazzo of Mississippi. Members joining us for the first time are Ms. Lawrence of Michigan, Mr. Chris of Florida, Mr. Case of Hawaii, Ms. Captor of Ohio, who in her spare time chairs the Energy and Water Subcommittee, and last but not least, Mr. Graves of Georgia. My colleague and ranking member of the Financial Services and General Government Subcommittee. Welcome, everyone. It's a privilege and honor to serve with you in this Congress, and I hope you find the work we do on this subcommittee as rewarding as I have. We will agree and disagree across many areas, but it remains incumbent upon all of us to get a final product out of subcommittee, full committee, and through both chambers of Congress that will make us proud. I remain committed to meeting the challenges ahead and doing that together. And I must say on a personal note that this has always been my favorite committee. I've served as ranking member here with Frank Wolf and with Harold Rogers. And so this is quite a day for me, but I have as much desire as my colleagues in the Republican side have to make sure that we get a bill out and get a bill passed through both houses. Now, I want to welcome Dr. Neil Jacobs, who serves as Assistant Secretary of Commerce for Environmental Observation and Prediction, and as of yesterday, NOAA's Acting Administrator. As of yesterday, right? And today? Not the acting. Okay. Congratulations. In this new role, Dr. Jacobs will oversee NOAA's $5.4 billion budget, which in addition to including NOAA's sea, air, land, and space observing platforms and the critical environmental data they provide, he will now also cover the wet side of NOAA and all of its work in fisheries and coastal management. Prior to joining NOAA, Dr. Jacobs served as Chief Atmospheric Scientist at Panasonic Avionics Corporation, was chair of the American Meteorological Society's Forecast Improvement Group, and served on the World Meteorological Organization's Aircraft Base Observing System Expert Team. Next, I also want to welcome Dr. Michael Freilich, who has served as the Director of NASA's Earth Science Division in the Science Mission Directorate at NASA headquarters since 2006. His creative retooling of the Earth Science Division's approach to research has been widely credited with protecting and enhancing the agency's vital work. Prior to his tenure at NASA, he spent most of his career as professor and as associate dean at Oregon State University's College of Oceanic and Atmospheric Science and member of the technical staff at the Jet Propulsion Laboratory in California. This statement is really a test on how well you can handle the English language, and being that English is the second language to me, I'm still dealing with it. Dr. Freilich, it is my understanding that you will soon be retiring from NASA. The agency has shined shoes to fill, given the many years you have dedicated to this field. Thank you for your service to the American people. We wish you well on this new and exciting chapter of your life. Both NOAA and NASA have critical missions. What they are observing, both above and below us, is affecting us in many ways. This hearing will help us learn from two leading experts about how climate is changing, how that will impact our country and economy in the short and long term, what research these agencies are conducting to help prepare us for the future, and how strategic investments from our subcommittee will help meet those challenges. Over the weekend, it was reported that the White House plans to name an ad hoc group of scientists with alleged ties to the fossil fuel industry to refute November's Interagency National Climate Assessment report that I have here. This is unaccountable working group. This unaccountable working group appears set deliberately cherry-pick data and science with the sole purpose of pushing back against the widely accepted science around climate change. This only serves to diminish the magnitude of this crisis, and it is dangerous. It also undermines the important climate research being conducted by devoted scientists at federal agencies like NOAA and NASA. As I have said many times, it is more than evident that our climate is changing and doing so very rapidly. The people of Puerto Rico saw this firsthand as they experienced the largest natural disaster in their history with Hurricane Maria. From the droughts fueling wildfires out west in California to hurricanes devastating the continental southeast year after year, our Earth is experiencing record temperatures that cause extreme weather, affect food supplies, and devastate local economies. The federal government must have the tools and resources it needs to study these changes so we can prepare and respond accordingly. The CJS subcommittee leads the way in this effort. Gentlemen, it's a privilege to have you join us for this important discussion and to learn from your expertise on this subject from the perspective of the agencies you represent. And as I told Mr. Cobbleson, who was the former chair of this committee, if we can't agree that there's climate change, can we at least phrase it in this way? Something's going on, and we have to look at it. Before we begin, I'd like to recognize my friend and colleague and a person I'm looking forward to working with and trying to reach agreement as much as possible so we can do the work we have to do. Mr. Adderholt for his opening remarks. Despite the White House's recent call for a new panel to review the science around climate change, the National Climate Assessment, along with the Intergovernmental Panel on Climate Change's recent report, these are the foremost documents explaining the changing climate and its impacts on the planet and society. For both witnesses, and if you could please just give me a yes or no answer to this, would you agree with that assessment?
Well, my agency was one of the 13 agencies that signed off on it, so based on the assumptions that they made on the RCP projections, yes.
And for the same reasons, NASA also signed off on it and was a foundational contributor, yes.
Thank you. Now I would like to walk through some of the top-level findings of the National Climate Assessment from the first two paragraphs of Chapter 1. It begins, Earth's climate is now changing faster than at any point in the history of modern civilization, primarily as a result of human activities. Would you agree or disagree with this statement?
Certainly, if you remove natural variation like INSO and PDO, then the remaining trend is anthropogenic.
Yes.
Continue from the report, and I quote, the impacts of global climate change are already being felt in the United States and are projected to intensify in the future. Would you agree or disagree with that statement? Jacobs.
There are all four scenarios, two of which were included in NCA 4, trend upwards, so yes.
Yes.
Further, the severity of future impacts will depend largely on actions taken to reduce greenhouse gas emissions and to adapt to the changes that will occur. Would you agree or disagree with that statement from the report?
It depends on which pathway you actually look at. The severity of 8.5 is obviously more severe than the other three, but certainly it's an undisputed fact that humans are producing the CO2 What is not discussed in there is the removal of carbon sinks like vegetation. So you can also increase the levels of CO2 by removing the sinks.
Thank you. So you're saying that there is human cause, but there are other causes too, as you believe.
That's correct. And in most cases, humans are removing the sinks as well.
And your answers?
Basically, yes. On the time scale of the next couple of centuries, what we do in terms of putting fossil fuel carbon into the atmosphere and not regulating, but removing and constraining carbon levels in the atmosphere will be the most important thing for defining our climate.
Thank you. Now skipping down to the second paragraph of the report, climate-related risks will continue to grow without additional action. Would you agree or disagree with that statement?
NOAA's role in that report was just providing transparent and defendable information as far as the atmospheric measurements. So that's beyond the scope of our agency.
So that's a yes or a no?
That's not what our agency's in charge of.
Yes, sir.
Similar answer from NASA. It's our job at NASA to make the measurements, to provide the understanding based on our research, and then to make that information available to you, the policymakers, to inform and guide your policy decisions.
Decisions made today determine risk exposure for current and future generations and will either broaden or limit options to reduce the negative consequences of climate change. That's another part of the report. Would you agree with that? Yes or no?
Well, the report actually discusses that it doesn't evaluate the feasibility or socioeconomic assumptions within the RCP. So that's also probably beyond the scope of our agency.
Doctor?
Decisions made today will influence the evolution of our climate, yes.
Thank you. Finally, and I quote, while Americans are responding in ways that can bolster resilience and improve livelihoods, neither global efforts to mitigate the causes of climate change nor regional efforts to adapt to the impacts currently approach the scales needed to avoid substantial damage to the U.S. economy, environment, and human health and well-being over the coming decades. Would you agree on that statement, with that statement, yes or no?
If the policymakers decide to address this, it certainly needs to be done on a global scale, not a regional scale.
And again, that is quite policy dependent. What we can do at NASA and in NOAA is based on our measurements and our understanding and our models. We can present to you the regional and global impacts of, potential impacts of policies that you may be considering.
Thank you for indulging me, gentlemen, with that, but I felt it was important to get all of that on the record. According to the U.S. government's best scientists, we're not doing nearly enough to avoid substantial damage to our economy and human health from the impacts of climate change. I thank you both for your answers. And Serrano, could you please contribute, if you have examples of how you are providing useful climate-related information based on your measurements to technical and non-technical decision makers?
One example of this is through our applications program, which is designed specifically to take the measurements and the understanding that we get from satellites and research and make focused information products that address the questions of non-technical users, such as, what are the statistics of surface wind velocities? What will the statistics of surface temperatures be? How will precipitation change into the future? These impact particularly people like architects and infrastructure designers who have to make decisions today about what the conditions are going to be 50 years from now when their buildings and infrastructure are still standing. We provide the measurements from today and the model estimates into the future in ways that can be accessed by, as I say, non-satellite weenies, that is, non-technical people, specifically through our applied sciences program.
Do you find any of the same discussion that takes place in general, certainly in Congress, about those who believe there's a problem, those who believe that the problem is not to you? When this information goes out, are there people who reject it and say, you know, that's not what I'm looking for, or I don't need that information, or it's not convincing enough?
The people on the ground need the information. Designers have got to, architects have got to design buildings, et cetera. So it's not a question of not needing the information. What we strive hard to do is to understand the specific information that is needed. And it's often very difficult for the user to articulate what he or she is looking for in terms of environmental information. And that's the role that our applied sciences program plays. It's sort of a flexible bridge between the non-technical users on the end and what we know and what we can provide on the other end. The key is to provide information in an accessible and efficient way to the non-technical user, not to present, you know, a course in environmental science for them. And that's what we try to do in our applied sciences program.
Thank you. Either one or both. Puerto Rico has been devastated by recent hurricanes, and the federal government, in partnership with the local government, are investing heavily in ecosystem restoration and repairing infrastructure. How are you educating the public and local officials about the increasing systemic risks to the island? Could you explain what specific impacts are expected there? Either one or both?
I can touch on that from two different aspects. One is just a general hurricane intensity forecasting work that we're doing, and not just on hurricane intensity, but also on track. So improving our capabilities of predicting rapid intensification and track within the weather models. With specific to that event, we did a lot of aerial surveys after we worked with the Department of Defense and acquired 2 Marine Corps radars to install so that we would have radar capability there after the storm. Another thing that we're working on is with the support of FEMA is actually studying the coral system around the island, because the corals are actually very important because they act as a way to dissipate wave energy. So about 95 to 96% of the wave's energy are dissipated by the coral reefs.
Another area of reaching out to the public about environmental impact relative to Puerto Rico that can be highlighted comes from the joint NOAA-NASA SUMI-NPP satellite, which was flying then and is flying now. It has an instrument on it called VIIRS that has an exquisitely sensitive day-night band. And so it can image during the night when there's only starlight or moonlight or not at all. Interestingly enough, when there is a natural disaster like in Puerto Rico and the power systems go down, areas that previously were bright because they had lights turn dark. And the SUMI-NPP images of Puerto Rico and other places have profound impacts on the public, because you can see the city was there and now this whole area is black at night because the power is out and remains out, and you can track how we are recovering from it. This is powerful connection between technology and public understanding.
Let me end by my round by staying there with for a second. and I'm sure there's arguments back and forth about this. Puerto Rico deals with hurricanes every year or every couple of years, but the phrase that's used is no one saw this one coming. To that extent, to the damage that it caused. First of all, do you think that's true, or that there was enough information out there to say that this was going to be a monster of a storm? Or did it catch people by surprise? Was it human failure in not being prepared, or was it so severe that couldn't have been prepared for it?
Well, I think what we're dealing with here is a forecasting intensity problem. Obviously, before satellite imagery, no one saw these storms coming if they never made landfall. But the capability that we have now, as far as ability to forecast track, really trails off around day 5. So that gives you roughly 5 days or less. That also requires that the storm is initialized in the model. So if there's areas of weakness in the model, it's trying to predict when the actual storm will develop. Once it's already there, the model usually handles the track fairly well. The other hurdle is rapid intensification. There's a lot of modification that the storm does to the water underneath it, and it's very hard to derive accurate sea surface temperatures from remotely sensed satellite data beneath the clouds that are obscuring the visibility of the waters. So, you know, that's one of the areas that we're focusing some research on right now with rapid intensification of hurricanes.
Thank you. Any comments on that?
No, NASA and NOAA are collaborating exceedingly well to get the information that's necessary to initialize the models and to understand processes such as rapid intensification. So you see that the models are improving year by year. The NOAA models are improving year by year by year.
Thank you to both. Some communities are already making massive investments to protect themselves from climate impacts. New York City, for instance, has a massive plan to build barriers to protect itself from another superstorm Sandy. These types of investments are enormous and should be made with the best possible information about climate change and the risks that it poses. For both of you, what are the most important investments to make in climate science and research so that we can reduce the uncertainty with regard to these risks?
I would say I would categorize the investments in 3 areas. The first one is observations. This is critical both for in situ observations, for initializing models, as well as validating predictions. And then the modeling, both weather modeling and climate modeling. We're slowly closing the gap between weather models and climate models. And we're actually learning from the development of both sides to benefit the other. The last one is investment in compute resources, both HPC and cloud-based compute resources, because in order to do these computations, it requires a tremendous amount of computing capability.
Spot on. Measurements, models, and communications of the results.
I'm hoping, Ms. Sandoval, that every panel we have from now on agrees with each other as much as...
NASA and NOAA have been working together extraordinarily profitably for an exceedingly long time.
I understand. Related to this, what do each of you consider to be the greatest unknowns in climate modeling today, and what are your agencies doing to address these?
In no particular order, I think the real challenges in climate modeling are understanding the feedbacks and the interactions, the various CO2 sinks, the cloud aerosols, and getting accurate initialization from those. And then understanding the natural patterns, because in order to isolate any sort of anthropogenic patterns, we need to understand the natural signals and be able to subtract those off.
Yeah, Dr. Jacobs, again, was spot on. I want to focus a bit on the natural extended sources and sinks of carbon dioxide, not the point sources. On average, about half of the anthropogenic CO2 that we put into the atmosphere stays in the atmosphere. The other half goes to the land and the ocean in ways that we don't entirely understand. And some years, almost all of the CO2 that we put into the atmosphere globally stays in the atmosphere. And in some years, almost none of it stays in the atmosphere for more than a few months. Understanding the sources and the sinks in the oceans and the boreal forest and how they interact and how they will change in a changing environment is critical for understanding what the atmospheric composition is going to be in the future and therefore the radiation balance.
Thank you. It's been a very interesting hearing and one that continues to be an issue of much contention. As I said at the beginning of the hearing, either in making a bad attempt at humor or being profoundly sarcastic, if we can't agree on what to call it, then maybe we can just agree that something's going on. And you folks are doing a great job at trying to find out what is going on and telling us, you know, what may be causing it or not causing it. But it would seem to me that there is a large amount of this, if not all of it, caused by we ourselves who inhabit this planet. And it's the planet we have. It's the only planet we know that we can be on right now. NASA hasn't shown us that we can be on another planet yet, although I think that's coming soon. But one of the reasons that I love this committee, and one of the reasons that I wanted very much to get an opportunity to chair this committee, or to be ranking member, as I was in the past, is because of these two agencies that are in front of us now. You do such important work and such important work for the American people and to help us along to understand where we are. And just for the record, as far as NOAA, I've always said NOAA is one of those agencies that really has to go out of its way to harm somebody, because it's always trying to help somebody. And to NASA, I say something very district constituency related. You've never seen a crowd react to a congressman bringing someone to a school as when you bring an astronaut. I mean, that is absolutely incredible. And we have to do more of that, continue to tie in the work of both agencies to the schools, because this excitement. I saw a group of kids just looking at weather maps and looking at NASA at maps taken on a trip to space, and they were glued to that screen. You go and the teacher said, "Okay, you in the back, relax," and it didn't happen. They were glued to it. So we should work on that. So thank you so much. Thank you for helping us through our first hearing. Wish I could say this is the last hearing of the season, but it's only the first. Thank you so much.